Hello, so let's do this problem. We want to determine if the number 397 is prime. Now, what we could do is we could just try dividing all prime numbers that we know up to 397 into 397. But if you remember from class that we know that there must be a prime factor less than or equal to the square root of n for any composite number n. So we can use this fact. Well, let's move on to the next slide. And so, well, what primes do we need to check to determine if 397 is prime? Well, first of all, we need to figure out what is the square root of 397. Well, I don't know it off the top of my head, but we can estimate. So, well, I know that 20 times 20, and you can check that that's just 400. So I know that the square root of 397 is just less than 20. So we can even say something like 19.9. So we need to check all primes less than or equal to 19.9. And what are they? Well, they're 2, 3, 5, 7, 11, 13, 17, and 19. So, right off the top, we know the number doesn't end in an even digit, so we know the number isn't divisible by 2. Let's check if it's divisible by 3. 3 plus 9 is 12, plus 7 is 19. 19 isn't divisible by 3, so the number isn't divisible by 3. The number doesn't end in 0 or 5, so the number isn't divisible by 5. 7 we'll have to check, I'll leave that for now, but we have a test for 11. So it's the alternating sum of the digits. So 7 minus 9 is minus 2, plus 3 is 1. 1 isn't a multiple of 11, so it's not divisible by 11. So what we need to check with long division. 7, 13, 17, and 19. So let's do that. So we need 7, 13, 17, and 19. So let's just do 7 right away. So let's check 7 into 397. So 7 5s are 35. I'll just do short division for this. So 39 minus 35 is 4. So I'll put a 4 there. 7 goes into 47 6 times for 42 with the remainder of 5. So 7 doesn't evenly divide into 397. 7 isn't prime. Let's check 13. So 13 into 397. 13 goes into 39 exactly 3 times. Bring down our 0, or subtract it to 0. Bring down our 7. 13 goes into 7 no times. So there's a remainder of 7. So it has a remainder. So 13 is not a factor of 397. Well, let's keep going. Let's check 17. So 17 into 397. Well, 2 17s are 34. So we'll subtract 34. We get 5. 5 is smaller than 17, so we made a good guess. We bring down our 7. How many times does 17 go into 57? Let's try 3. That's 51. So we get a remainder of 6. So it doesn't evenly divide into 397s of 17 isn't a factor of 397. The final prime we need to check is 19. So let's give it a go. So 19 and the 397. So 19 goes into 39 twice, so that's 38. Bring down our 1, 7. 19 goes into 17 0 times, so it has a remainder of 17, so it also has a remainder. So we know that by our divisibility rules that 397 is not divisible by 2, 3, 5, and 11. And so we needed to check using long division 7, 13, 17, and 19. And it turns out that none of these divide evenly into 397. So we can conclude that 397 is prime. And we're done. We'll put a little happy face. And we've shown that 397 is prime.